Here's something to be proud of. A Northeast Ohio engineer is being credited with an invention that could revolutionize how engines are made. News 5's Clay Lepard explains it's this new lighter and stronger metal that could generate billions.
Nickel cobalt chrome seemed like a really nice alloy to start with, but now we had to figure out how we're going to incorporate oxides into our process and into our printed part. We did start with mechanical alloying just really briefly, and the issue, what we found was that when you mechanically alloy and you're trying to basically mechanically force those oxides into your metal powder, you destroyed the morphology of that powder. What was used to be very spherical and able to flow in your 3D printer to build parts is now deformed, much more platelet-like. It has a tendency to stick and becomes much more difficult to print. And so you keep incorporating other defects and issues into your powder when we try to do that. And so we kind of quickly gave up on pursuing mechanical alloying as a route. And what we ended up doing instead was actually coat the nickel cobalt chrome powder with nanoscale yttria.
The secret? The metal powder is coated with a ceramic before it's printed. But this happens at a nanoscale level. Particles so small, they use sound waves to get the correct mixture.
So basically what we do is we take nickel cobalt chrome powder that we purchased and put about 1% yttria into a container. And we mix it with this new acoustic mixing technique, that high energy mixing technique. And what happens is that nanoscale yttria coats the nickel cobalt chrome powder. You can kind of see here in a cross-section cut of a coated powder, you get about a layer of 250 nanometer thick of yttria surrounding the nickel cobalt chrome. And the EDS kind of helps confirm that right there. Another way we can look at it is looking at nickel cobalt chrome powder before coating and after coating. And you can kind of see here, uncoated is on the left, the middle is coated. And really, we get this really nice, dense coating on all our metallic powder after this coating step. And if you really zoom in, it kind of looks like we get some nice compaction of the yttria with also some loose particles on the surface of our metallic powder. And so what was really exciting was, one, it didn't deform the metallic powder. We still had very spherical powder after the coating step. And when we used Hall flow tests to explore the flowability of both pre and coated powders, what we found is that, at least qualitatively, it didn't appear to affect the flow of the powder at all after we coated it. And so we felt pretty confident that we were going to be able to put it in the 3D printer and actually work with the coated powder. This advanced dispersion coating technique can successfully coat metallic powders with nanoscale ceramics. And a point that I didn't really make earlier in the slides was we strongly believe, and we have early results showing that we really can take almost any metallic powder and coat it with almost any type of ceramic. And so really, the design space of new materials is huge using this new coating technique.
This is Linde Research Center. Clay Lepard, News 5.
Is that amazing or what? I love that. I hope, Tim, you're getting paid, man.